when you guys were working on this the other day and I was walking around, it looked like a lot of people were having trouble. So I thought it would be worth going over a few of these problems. Number one, we want to draw the graph of that function. It says be sure to determine and label the vertex as well as the x and y intercepts. How do you find the vertex of that function? Close. Not -3, -1. +3, -1. Why is it +3, -1? Inside the parentheses, determine left and right, and it works backward. A -3 is right 3. And then that -1 is a down 1. So our vertex is 3, -1. How do you find the y-intercept? How do we always find the y-intercept? The y-intercept is usually the easy one. Plug 0 in for x. To find the y-intercept, x equals 0. If I plug 0 in, I have 0 minus 3. That's -3. -3 squared is 9. 9 times 2 is 18. 18 minus 1 is 17. So I have 0, 17, which is way up top somewhere. Somewhere way up there. Now, how do you find the x-intercepts? 0 equals, for which letter? Y. To find the x-intercepts, you use y equals 0. So that one's a little bit of work. You're going to have 2 times x minus 3 squared minus 1 equals 0. Yeah, now how do you solve that equation? Plus 1 on both sides, and then divide by 2, and then square root it. So which technique are you using?
Linear.
No, it's not linear. It's definitely not linear. It's quadratic. It's got a square. Is that factoring? Is it the quadratic formula? No, so it must be the other one. What was the other one? You didn't complete the square. The square is already completed for you. Square root method. You did square roots on both sides. Is the quadratic formula always the best way to solve a quadratic equation? No, and this is a very good example. You don't want to solve this one using the quadratic formula. To use the quadratic formula, what you'd have to do is you'd have to do the squaring, you'd have to FOIL that out, then run the 2 through, combine all your like terms, and then use the quadratic formula. I think that's a lot harder. This is a good example of the quadratic formula is not the easiest way. So we add the 1, we divide by 2, we do square roots, and then we add 3. So x is 3 plus and minus square root of a half. So where's that on the graph? Where is 3 plus the square root of a half? How do I draw that on my graph?
You go right 3 and then up or down.
Nope, I don't go up or down. What's my y value here? Y is 0. So where is 3 plus the square root of a half? There's 3. Where's 3 plus the square root of a half? Yeah, it's over just a little bit, isn't it? It's somewhere between 3 and 4. So you just kind of put a dot somewhere between 3 and 4, right about there. There's 3 plus the square root of a half. And 3 minus the square root of a half is somewhere between 2 and 3. So you have to kind of estimate those intercepts. You can't really graph them exactly. They don't come out to be nice numbers. That happens. All right, so there's our parabola. Questions on that? All right, how about the second one? How would you find the vertex on that one? Right. Remember this one, I think, when we go to find our x-intercepts, this one I think is one we're going to want to use the quadratic formula. So remember the quadratic formula, negative b plus minus square root of b squared minus 4ac all over 2a. If you know this formula has the formula for the vertex within it. What was the formula for vertex again? Negative b over 2a. So just this part of it is the formula for vertex. So that's how I would find the vertex. I would use x equals negative b over 2a. Negative b is 6, and 2a is negative 6, so that's negative 1. Plug it in, and hopefully you'll believe me. When I take negative 1 and plug it in, I get an answer of 4. So I have negative 1, 4. So there's the vertex. I think that's the easy, quick way to find the vertex for this problem. Use that little formula. All right, how about the y-intercept? What's the y-intercept? 0, 1. Finding the y-intercept is very, very easy for this problem. You plug 0 in, you get 0 minus 0 plus 1. That's 1. Finding the y-intercept is almost always very easy. You plug in 0. X-intercepts. To find the x-intercepts, got to do a little work. I've got to take negative 3x squared minus 6x plus 1 equals 0. Now you have lots of options. You can try to factor. You can not use the square root method, but you could complete the square, or you could use the quadratic formula. Which way do you like? Anytime this first number is not the number 1, my answer is I use the quadratic formula. I think that's the way to go on this problem. So x equals negative b is going to be 6 plus and minus the square root of b squared. How much is negative 6 squared? Positive 36 minus 4 times a is negative 3 times c is 1. Divided by 2a is negative 6. Go ahead.
When it's under the square root like that, you kind of separate that 36 and then do the other ones and whatever it comes out, you minus or add.
Yeah, that's what I do. Is the b squared, I usually just do that in my head and write it down. And then I write the minus 4 times a times c. And then typically I grab my calculator. And I just grab my calculator and I type 36 minus 4 times negative 3 times 1. I think that's easier than trying to do it all in one step or splitting it into extra steps. So that's square root of 48 over negative 6. So there's the x-intercepts, but the reality is that really doesn't do me very much good. How do I graph 6 plus the square root of 48 over negative 6? Where is that? I really don't know. So I think in this case, it makes a lot of sense to get a decimal. So I think I would go 6 plus square root of 48 and then divide by negative 6. So one of the answers is about negative 2.15. So now I know where to graph that. Negative 2.15, 1, 2, right, just past negative 2 right there. And then I think I would do the same thing with 6 minus the square root of 48 divided by negative 6. And it's 0.15, just a little bit bigger than 0. So I think that's a good example of having the exact answer is okay, but it's really not very useful. I think this is a good example of where decimals are more useful and better for you. All right, so we connect the dots, and there's our parabola. Questions on either of those two problems?
So you would say at that point we should always just use our calculator?
Absolutely. Yeah, use your calculator to get a decimal approximation there. Makes the most sense.
Like, in our calculator, do we have to, like, actually put, like, plus or minus? Like, I don't know what that is.
There is no plus or minus button on your calculator. You have to do them separately. You have to do one of them with 6 plus the square root, and then type it in again with 6 minus the square root.
Still just end up being bad. So just put the negative sign.
Well, no, because this one was
Oh, yeah.
negative 2.15, and this one was 0.15. So they won't come out to be one positive, one negative like that, the exact same number. All right, how about the second page? Any problems with, I put it so you can see it. Any questions on problem 3? C. Yeah, that was the one I saw most people struggling with. Do what? Get rid of the fractions. Exactly. Anytime I see an equation, and my equation has fractions, the first thing I do is I get rid of them. The reality is, the quadratic formula will work just fine with fractions, but it's kind of a pain in the neck to do. So I wouldn't. What I would do is I would look at those fractions, and I would find the common denominator. What's the common denominator? 6. So I'm going to take this equation, and I'm going to multiply everything by 6. What's 2/3 times 6? 4. So that's 4x squared minus, what's 1/6 times 6? 1, so that's just minus x. Plus 1/2 times 6? 3 equals 0. So that would be my first step. Get rid of the fractions. Don't mess with the fractions. Clear them out. Now I have to make a decision. Do I want to try to factor? Do I want to complete the square? Or do I want to use the quadratic formula? You just factored? Okay. It factored?
Yeah,
It did factor. All right. So, let's see how good a guesser I am today. If it's going to factor, I'm going to guess it's 4x and x. And then I think it's got to be a 3 and a 1. And how about a -1 and a +3? That's how it factors, I think. Because if I do a quick FOIL, I'd have 4x squared. I'd have a -4x and a +3x. That would give me a -1x. And then, oh crap, 3 times -1 is -3. I don't think it factors.
I got 4x plus 1, x minus 1. And then
4x plus 1 and x minus 1? Well, that's no good, because if I have a 1 here and a 1 there, 1 times 1 is going to give me 1. There's no way I'm going to have a 3 on the end. All right, I don't think it factors. Again, my kind of rule of thumb is, if this first number is not the number 1, I'm jumping right to the quadratic formula. So I wouldn't have even tried to factor, in my opinion. All right, so I would have said x equals negative b. How much is negative b? 1 plus or minus the square root of b squared is 1 minus 4 times a is 4 times c is 3. All over 8, 2a. 1 minus 4 times 3 is -47. So x equals 1 plus and minus the square root of -47 over 8. But I wouldn't leave my answer that way. I would do one more little step. What's my last little step? Change the negative underneath my square root to an I. So I would write my final answer as 1 plus and minus I square root of 47 over 8. That's a 47 there. Kind of goofed it up. Questions on that? Right, so we had pretty much the same thing when we had linear equations. When we had a linear equation and our equation had fractions, the first thing we did is clear the fractions. Do the same thing for a quadratic equation. If you have a quadratic equation with fractions, clear the fractions, get rid of them. All right, how about the last one? The average state cigarette taxes per year are listed in the table below. Determine a quadratic model for this data where t is a number of years since 2000. Round all values to 3 decimal places. What's it asking you to do there? Type this data into my calculator, and then I want a quadratic equation. So which regression am I going to use? Quad regression. All right, so go to my calculator. Stat. Edit. What numbers am I going to plug into L1? 1 through 7, because it said use t being years since 2000. So I'm not going to plug in 2001, 2002, so on and so forth. I'm just going to plug in 1, 2, 3, 4, 5, 6, 7. And then I go over here to my L2, 43, 61, 73, 78, 92, 100, 107. So I type my data in. Now, how do I get that quadratic regression thing? What buttons do I push? Stat. Move over to calculate. Number 5, quadratic regression. And I have the newer operating system. L1, L2, those are correct. Just go down to calculate. If you have the older type system, you just hit enter again, and it does it for you. All right, so the answer would be, it's a round to 3 decimal places, so I would write y equals minus 0.679 x squared plus 15.75 x plus 29.714. So the directions told me to round to 3 decimal places, so I did. There's my answer. With everything rounded to 3 decimal places, the middle one was, the calculator only gave me 2 decimal places, so I went with 2. Predict the average tax per pack in 2013. What are you going to do there? You're just going to plug in 13 for the x, because it's 13 years since 2000. So x equals 13. Y is, I grab my calculator, I'll type it up, minus 0.679 times 13 squared plus 15.75 times 13 plus 29.714. I get 119.71. And I rounded to 2 decimal places. Why did I round to 2 decimal places? Actually, I think a better answer would have actually just been 120. Why is 120? Why is rounded off to 120 a better answer? Yeah, what are the units here on y? The units are, well, not whole numbers. I think it makes more sense to put them in whole numbers. What's this? Average state tax. What units are on the average state tax? Cents. That would be my guess. It doesn't tell us, does it? But I would guess that's the tax in cents. So I think it makes the most reasonable answer the 120 cents. Predict when the average tax per pack will be 144 cents. What are you going to do there? Y is 144. So I need to solve 144 equals negative 0.679 x squared plus 15.75 x plus 29.714.
What tells you that, like that, being as an average tax? Like, if I'm reading that, what would indicate that?
Well, x is clearly the years. So now they're asking us predict when. So we want to find the year when the tax is 144. Tax was the y values. So they're telling me the y value is 144. I need to find the x. How do you solve that equation? Set it to 0, so I got to subtract 144. So I need to take 29.714 and subtract 144. I get 0 equals minus 0.679x squared plus 15.75x minus 114.286. Okay, good. What's next?
How do you get 114.286 if it gives 29?
You just
I did a minus 144 on both sides.
No, but you have to subtract it from 29.
144 minus 29.
I did
29.
29.714 minus 144. And it told me minus 114.286. I just believed my calculator. You didn't do that?
Well, my calculator didn't. My calculator said it was 84, negative 84.286.
Is it being,
I have no idea how you got negative 84. Unless you typed in, well, the only way that would happen, if you typed in 59.714, did you type it in incorrectly maybe? Don't know. Don't have the work anymore. You must have typed something in wrong. All right, so anyway, how do I solve that equation now? I have three choices. I can try factoring, I can complete the square, or I can use the quadratic formula.
it's not one in the front?
It's not one in the front, so I definitely don't want to factor. With all those decimals, I don't want to factor either. I don't think I want to try completing the square with all those decimals. I think the only reasonable plan of attack is the quadratic formula. Quadratic formula works with decimals. It's just kind of a pain in the neck. That's all. So there needs some more room here. So we're going to have x equals negative b. Negative b is going to be negative 15.75 plus and minus the square root of b squared. That's 15.75 squared. That's 248.0625 minus 4 times a is negative 0.679 times c was negative 114.286 divided by 2 times a. So I'm going to just do that part of my calculator, I guess. 2 times negative 0.679 is negative 1.358. All right, so now I'm just going to take my calculator and I'm going to clean this all up. So I'm going to have negative 15.75 plus and minus. All right, I'm just going to type this in here. 248.0625 minus 4 times negative 0.679 times negative 114.286 equals. I got negative 62.33 something something. And that tells me I can stop. I've done all the work I need to do. What do I mean by that? I have imaginary answers, don't I? But x is supposed to be a year. Do we have any imaginary years? No. So what does that tell me? It's not real. So it'll never happen. When will the tax reach 144? Never. Because when I tried to solve this equation, I ended up with imaginary answers. X can't be imaginary for this problem. We don't have imaginary years. So our answer would be Never. It will never happen, according to this equation. Questions on that? All right, so that's that for today. All right, today we move on to section 7.6. Section 7.6, we're going to talk about solving 3x3 systems of equations.